taking half a step toward a wall. Alright? And some of y'all are like, what are we talking about? Well, I'm going to show you. Hopefully it won't confuse you. Let's say that we have a wall. Let's say that this is a room. And this is a wall of the room. And you're standing right here. And let's say that you're so many feet from the wall. And I tell you, this is you. And I tell you that I want you to do an experiment. I want you to take a full side step to the wall, but each side step after that, I want you to take half the previous step. So let's say that you got a 4 foot, I'm talking about a side step like this. You can do walk forward, you can do that, but it's easier to think of it as a side step. Let's say that you have a side step of 4 feet, and the reason I use 4 feet is because it's easy to start off with. Let's say that your side step is 4 feet. The next side step you take is going to be what? 2 feet. The next side step you take is going to be what? 1 foot. The next side step you take is going to be a half a foot. The next side step you take is going to be a quarter of a foot. The next side step you take is going to be an 1/8 of a foot. The next side step you take is going to be a 1/16 of a foot. The next side step you take is going to be a 32nd of a foot. The next side step you take is going to be a 64th of a foot. The next side step you take is going to be 1/28th of a foot. Next one's going to be what? 256? Yeah. So what's going to keep happening? It's going to get smaller and smaller and smaller. Do you ever reach the wall? No. Mathematically, I can't even spell with this pen sometimes. Mathematically, you never, and you got to express, put a little bit of expression on never. You never reach the wall. Now, why did I say mathematically? Because you can't take a 256 foot, you can't take those strides. Okay? You're getting down to this right here, you can't do it. All right? But mathematically, you never reach the wall. Now, this is basically what the limit theory means. Okay? You get close to and close to and close to, but you never actually what? Reach the wall. How close do you get to the wall? Infinitely close. Why did I say infinite? Why did I say real close? Because you keep dividing. You keep getting close to the wall, right up to it, but you never do what? You never do touch it. Now, if you go into calculus with the redneck attitude, I don't understand that, that's stupid, well, then you're going to fail. But if you go and you try to think about actually touching the wall, do you actually reach the wall, then the limit theory will not be out there in left field for you. You have to actually think. Okay, the next one is, I have no idea, 512. 1 over 512, 56 and 56, I don't know what it is, but anyway, it just keeps getting bigger and bigger and bigger. The denominator keeps getting bigger and bigger and bigger, so therefore your step keeps getting what? Smaller and smaller and smaller. So you're just going to start getting smaller and smaller and smaller and smaller and smaller. Now, you take this guy, and you take that same limit thinking really. And you apply it to a little bit of algebra. Take the limit and you put it with this algebra concept right here, which is a nonlinear bisected or intersected with a linear. And basically you have calculus. All right? Now, back in algebra, you plot these 2 points and you draw a straight line and boom, you go to the next problem, right? The difference between calculus and algebra is that calculus, you move. Okay? In other words, this thing, I can't do it on here, but I'm going to ask you to use your imagination. This is basically called a what line? It's a secant line because it's on the interior of the curve. All right? Secant line doesn't help us. We want the tangent line because that's the objective of calculus, taking the derivative. We're finding the equation of the tangent line. And that helps you in physics because if you know the tangent line of a particle that's moving, then you can find the normal line and you can find all kinds of good stuff about it, the velocity and all that good stuff. So one of the things we need to do is find the tangent line. So how do we do that? Well, we take this limit theory, this half of a half of a half of a half of a half, and we apply it to this dot right here. And what happens to that dot? Well, that dot, well, let me do this before I get ahead of myself. Let me do this. This guy is, let's say that's X.
The dot is
the dot, yeah. And this right here is what? F of X. Everybody with me? Oh, just think of your pre-algebra, X and Y. And then this dot is X plus, I'm just going to call this distance right here H. Okay? Then what is this point right here? How'd you know that? Who knew that?
Just guessing.
How'd you know that? Think you know everything, don't you? No, I'm just kidding. Now, find the slope of that line. I want you each to give me the formula for the slope of that line. Huh? The straight line. Because that's what we're going to work with. You're going to move the secant line. You're not going to move the curve. Why are you not going to move the curve? Well, you can't move the track of a particle in space. You can manipulate it, but you can't move it. Some of y'all are going, what the heck is he talking about? In Calc 3, you're going to, that's all you're going to be doing, is you're going to be looking at a particle in space and how it goes around and around and that kind of stuff, and how it goes, and measuring it and following it. You know, not just plotting it, but you're going to plot it and you're going to move it and you're going to find out how fast it's going around an axis using calculus. Okay, now your algebra. What is the slope of a line? Good job. Except you got it, I think you got it backwards. Yeah, you screwed up. You screwed up the whole class. Now the whole class is going to fail because of you. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, now that I brought that back to your memory, and now half of you can do the problem now. Plug and shove. You don't even numbers. No, I don't want you to plug in numbers. I want you to plug in the notation. Which way do we read? Unless you're from Middle East, Masalama. So which one's the first point? This one. And this one is the second point. So, this point, if you wanted to write it in terms of a point, is x, f of x. And this point is x plus h, comma, f of x plus h. Oh, well, you get the whole. There. F of x plus h. So, something I tell all my algebra students, I always put parentheses whenever I do this. Right, Mr. Brooks? Yes, you agree. Whatever. All right, so where is my y sub 2? F of x plus h, Hubert. That's right, class. Minus what?
F of x.
F of x. Over? X plus h. Minus x. Everybody with me? I mean, all you did was the slope formula that you learned back in Algebra 1. Now, what does this give us? Look here. F of x plus h minus f of x over h. Anybody know what that's called? Say again? I'm sorry.
The derivative?
It's called the difference quotient, which gives us the derivative. Yes. How did you know that? Okay. So this is, and that m comes down. So basically, this is the slope of that line. Now, that's algebra, right? Because I told you you learned it in algebra. Now, we apply that limit theory to this and take out this m right here and say, let me take out the m. Okay, I don't understand this. In 236, when you turn it over and you use this thing, it erases. But not in this class. You've got to touch this thing and do it. Delicious ball. Now, I take the algebra that we learned in Algebra 1 and I apply this thinking right here and I go limit as h approaches what? 0. Now, what does that mean, Hubert? Well, what's h? Right here. So let's take our handy-dandy highlighter and let's highlight that right there. So let's say h is 8 foot right now. So take half of 8 foot. 4 foot. Take half of 4 foot. 2 foot. Take half of 2 foot. 1 foot. 1/16th, 1/32nd, 1/64th, 1/128th. And eventually, this line is going to be right beside that line. Infinitely close, but not touching. And what that does is that takes our little red dot right here, which it won't do it. I know it won't. I didn't think it would. And it takes that little red dot and it puts it here and here and here, and here, and here, and eventually it just starts getting closer and closer and closer and closer and closer until it gets right up to this dot. Now I'm using this dot because it's big enough for you to see. But that dot is about you can go to the end of a pencil point that just has been sharpened. And you're getting right up close to this dot, and get right up close to it, get right up close to it. What does this line turn into? The secant line turns into the what? And I'm just going to draw one last line right here between these 2 points. And what is it? This last line right here, somebody tell me what it's called. The tangent line. This last line right here. I'll draw it in blue. Well, that ain't going to work. Hold on. This line right here. Because it's crossing the last point right there. That's infinitely close to the original point. Now, at that point, what is H approaching? Right here. 0. So when you approach, when H approaches 0, your secant line has turned into the what? Tangent line. And that's the goal of your first part of calculus, the derivative. Okay? Now, of course, we haven't got to derivatives yet. We haven't even finished limits yet. After we finish limits, we will go into the derivative, the quotient rule, the difference quotient, and then the derivative. But I'm not going to do all that and just say, okay, now you're doing calculus. I'm explaining to you where we're going. This is your algebra that you learned in Algebra 1, Algebra 2, college algebra. This is your algebra, the first part of this, where you plotted the points and have a straight line and a curve. That's algebra. This is limit theory, which is the first part of calculus, which you got to learn this. You got to get this in your head so you can understand and what happens with that line. Now, I guarantee you there's somebody in here that's had calculus before that was not explained it that way. And now you start to understand it. You understand what that, you've seen this picture before, but you didn't understand it. Okay? Now, hopefully, breaking it down to the slope that you learned back in algebra, you understand it a little bit better. Yes, sir?
You said that the tangent line was going to be the last line, right?
Yeah, that line right there is the blue line.
But if it just keeps going, like if it just keeps getting smaller.
When you're thinking, as it approaches 0, it gets to a point. Why did I stop drawing these legs right here? Why did I stop?
You wouldn't be able to see it.
You wouldn't be able to see it. And you get to a certain point that you're right up against these 2 dots, or like I say, they're the end of a pencil that's just been sharpened. And those 2 dots are so close together that you can't even see it. So that's the last point that you're thinking of, where you got the 2 points so close together that you can't move them close together without touching. So you got to think out of the box a little bit. Okay? Questions on this so far? Now, in order to understand the limit, they want you to go through a little bit of algebra and a little bit of limit thinking limits and do some problems. Whatever. Here, they're basically doing the same thing that I did, except I did it with the side step. They're doing it with numbers. Okay? So don't worry about that. What I would like to show you is some things that we're going to be doing. the algebra problems that give everybody fits. Okay, I'm getting there slowly but surely. I don't know why this thing is doing that. I think one of y'all is doing it. Somebody's got a remote control or something that's missing with my computer. I don't know why it's doing it. I'm sorry. Okay. Here they're getting you ready. They're talking about limit. Then I explain limit a little bit different from the book. So hopefully, if you don't get it, use the book. But that's the way I do it. Here they're trying to show you getting closer and closer and closer and closer and closer. But what I want to show you is problems well, if they ever get there. Good gracious. Okay, they're still going into limits here. They're still graphing the limits. I'm not interested in that. I'm interested more in, okay, here we go. The page, for those of you that have a book, page 95, the limit laws. You need to write those down. If you don't have a book, I'll blow them up a little bit for you. There they are. Write those down right quick. Basically, you can add, subtract. You can move the constant out. If you have a limit, you can pull the constant out to the front. You can multiply limits, and you can divide limits. Now, I guess this would be the first thing that's testable. Your first unit test is going to be on limits. And it's going to be on limits and algebra. Limits and algebra. That's all it's going to be. This is the first thing that you can be tested on right here is these properties. Now, when you're talking about a limit, the notation that you're going to see is the notation with limit. And again, I don't know how much you remember from your pre-cal class, but limit as x approaches a number, let's say 2. And the function is, let's say, x plus 3. All right? And on that x, as the x approaches 2, you might see a little sign like this, with plus, or you might see a little sign with a negative on the right here. Now what that means is, as you're approaching 2 from the right or the left, again, I don't know how much y'all remember from your previous classes, so x plus 3, it's got a y-intercept of 3, and it's a line 1 to 1. So there's your line. And they want to know what is the limit as x approaches 2. And let's say from the... Now, did y'all see that? It worked that time. From 2 from the right. Well, x equal to 2. Let's see, 1, 2. So what you need to do is think of this guy right here just coming down through here like this. That particle coming down through there. And 2, you're approaching 2 from the what? From the right. So, and as this guy approaches 2 from the right, your particle is doing what? It's coming down that line. What is it approaching? Well, looks like at 2, well, just plug it in. 2 plus 3 is what? 2 plus 3 is 5, Hubert. That's right, class. So you plug in 2 and you get 5. So what is the limit? 3, 4, 5. As x approaches 2 from the right, what is y approaching? 5. And yes, it's approaching from the left also, because it's a straight line. Now, it's not going to do that all the time, because you're not going to have a straight line. Sometimes you have a curve, sometimes you have a divided line, sometimes you have a divided function. All right? So it's not always going to be that easy. Okay? And what we're doing right now is we're doing graphically. This is graphic. I'm showing you how to do it graphically. Look at the graph and approach 2 from the right, and that's here's your eyeball. I mean, not your eyeball, but what your eye sees. It's like a tracking system. You're coming from the left, and as you're coming from the left, that particle is coming from the left too, right? And it's approaching, ding, it's approaching 5. All right, now, there's 2 or 3 types of students in here right now. One is going, oh yeah, I know how to do that. The other one is going, okay, I remember it a little bit. The other one's going, okay, I don't know what he's talking about. You have to look at it from a non-algebraic point of view. What do you mean non-algebraic? When in algebra, what did you do when you plotted this point? You went here, you plotted this point, and then you drew a line, and then you went to the next problem. You can't look at it from that now. You got to, that box is closed. You get to reach into it, but you can't think like that anymore. You've got to think as a tracking system. You've got to think in motion, because that's what calculus is. You've got to think in motion. Everything that you do from here on out has got to be in a tracking motion like this. And I can't do it because I'm going to draw on it. But you got to think, okay, see, it's not going to let me do it, but like that. Everything now has got to be in motion. I've got a CD. I didn't bring it. I need to. But I've got a CD which you can actually see, a DVD, sorry, that you can see the actual motion. And I'll bring it. I'll go get it when I get y'all on the problem. I'll go get it. But this is from, and I'm looking at y'all. Y'all are quiet, and I don't know if y'all think I'm crazy or not, but I'm trying to get you to think in terms of tracking, because you've been thinking in terms of, okay, plot a point, go to the next problem. You see what I'm saying? Now you've got to think in terms of motion. Okay? I hope that helps. Now, if I was approaching from the left, then you got to think in terms of, okay, it's going to erase it. I'm sorry, but I've got to do it. Infinity. Like that. Everything that you think of in limits, you've got to think of in motion. Okay, so that's the first thing you need to study right there. It's kind of like the exponential laws. It's not rocket science. If you have two functions, you can multiply the limits. You can add the limits. It's not that big a deal. When I get to the part that's going to make up your Unit 1 test, I will hammer it. Okay, and that's where you use algebra to find the limit. And when I get to it, we're going to spend a lot of time on it. That's the way I do things. Okay, here's some more rules right here on page 96 that you need to be aware of. Notice I didn't say, detrimental, but you need to be aware of. I'm trying to pull it up. Yeah, just come on in whenever. So I hope you got breakfast and enough beauty sleep. Wish we could stay in the bed till 8:30 or 9 o'clock.
Yeah, I just love, sleeping in half of my classes,
Yeah, that's all right. We just had a quiz and it's 30th grade. You missed it.
Well, I'll just give up.
There you go. This one right here is important. Limit of a constant is always going to be the constant. So, and teachers love to put these on tests. Limit of 2 is 2. Because basically, what do you have? You have x is equal to 2, and that's a limit. That's a line that's parallel to the x-axis. Y-axis. Okay? And we'll go through some of these as we do problems in algebra. This one right here. Limit as, I can't even read it because it's so blown up. Does that say x approaches a? Yeah. Of any function to the 0. Is that to the 0 power? Let me look at the monitor. I can't see. It's so blown up. Huh? To the n power, you can put that n on the outside. Okay, that's what they're saying there. So these are just like exponential laws. You just got to, it's another way to rewrite. I'm blowing this up a little bit. There we go. I think if I blow it up, you can see it a little bit better from here. And then move it up. I'm trying to get you to see it because I know some of you don't bring your books. Well, that must be as far as it'll go. Yeah, that's as far as it'll go, so I got to scroll down. There, is that clearer? Yeah, I think that's clearer.